Welcome to a lesson on permutations and combinations. This is lesson 1, the basic counting theorem. And the basic counting, the introduction to counting. So many times you want to count the number of things, number of ways something can happen, number of different outcomes, or the number of different choices. And obviously we're not speaking about, counting 5 apples or something. We're speaking more about really when the numbers get really big, 100,000 different ways you can choose something. Then we use counting techniques in mathematics. And I guess when we get to the examples, it starts to make a bit more sense. But yeah, suffice it to say, when things get impossible to count by hand manually, we use mathematics to make things easier, more systematic, to count things in a mathematical way. So basic counting theorem says that if you can choose, if one event can happen m different ways, if you can choose something m different ways, and then after that has occurred, another event can happen n different ways. Okay, so the first event, m different ways, second event, n different ways, then the two events can occur one after the other in m times n different ways, m times n. Okay, and obviously if there's more events, if there was an event after that, you'd multiply that as well. So this is called like the multiplication principle. And here's an example of it. Let's say you have 3 different ties and 5 different shirts. If you choose an outfit for the day, how many different possible ways can I choose an outfit? How many different outfits can you make, I suppose, with 3 different ties and 5 different shirts? How many different outfits are possible? And our first choice is going to be a tie, and our second choice is going to be shirts. And so using the multiplication principle, we'd say 3 times 5. Okay, so you have 2 events here. First, choosing a tie. We can do this 3 different ways. 3 different ways. Second event is choosing a shirt. You can do this 5 different ways. So if you had a box diagram, and we actually use these box diagrams a lot, and look, you can do it like this. And the idea is how, the first choice, your first event, and you write a number here. How many different ways can you choose a tie? And obviously the answer is going to be 3. How many different ways can you choose a shirt? And it's going to be 5. And you're just going to multiply these. Now I've seen, I tend to do it just like this, because it's just quicker, like dashes, and I write 3 and I write 5, and then the implication is it's always going to be multiply, so I don't even write the multiplication thing. But anyway, just to start off, to help you think about it, I guess, how many different choices can I make? That's what you put over here, right? Choice number 1 is 3 different ways, and then there's going to be a multiply here. Choice number 2, 5 different ways, and 3 times 5 is 15. And look, let's say for example, you guys are starting off, maybe you're skeptical. Can you really make 15 different outfits if you had 3 different ties and 5 different shirts? Well, let's check. Let's say you had a red, blue, and yellow tie. So you have 3 ties. A black shirt, grey shirt, pink shirt, white shirt, and a purple shirt. Let's say 5 different shirts. So we're expecting 15 different combinations, and I've actually listed all of them out here for you. And you will be able to see that there are 15 unique outfits you can make. So let's do some past paper questions. I mean, that's pretty much it for lesson 1. We're just going to look at applications to exam questions, I guess. See how it works. So for example, the New South Wales number plates have 3 different letters, then 2 numbers followed by a letter. How many number plates with this configuration are possible? Okay, so imagine this is a number plate. How many choices can you have over here? How many different things can go into this box? And because we know the first 3 have to be letters, there are 26 letters. So you can put A there, you can put B there, you can put C, D, E, F, G, H, I, J, K, L, M, N, O, all that stuff. 26 can go over here. Choice 2, it's also a letter, so also 26. Now, there's no part of the question which says to us that we cannot repeat letters. Sometimes they'll put a condition. If you can't repeat a letter, then 26 will be here, and it'll be 25 there, because you can't repeat whatever letter you put in the first box. But over here, that's not the case. They haven't given us any conditions. It's a basic question. So 26 can go in the first slot, 26 letters can go in the second slot, 26 letters can go in the third slot, and it's followed by then 2 numbers. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 10 different numbers, and 10 different numbers here as well, and then followed by a letter at the end. So it's going to be another 26. And if you just use index notation, that's 10 squared times 26 to the 4. Obviously, when the numbers get really big, then you don't necessarily need to put this in a calculator and write down your actual answer. This should be acceptable. That's fine. That's when the numbers are really large. Okay, so moving on to the next example. Next exam question. How many 10-digit numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 if the first digit cannot be 0? And so, this is how you do it in an exam. You drew 10 dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-digit number. I've got 10 there. And you're allowed to use those numbers, but the first digit cannot be 0. So how many choices do you have for the first digit? And the answer is 9. Because you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, but you can't have 0. Now for the rest of them, now notice that repeated digits are allowed. You are allowed to repeat digits. And so the second slot, you can have 10 different numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 0 as well, so 10. And yeah, it's just going to be 10, 10, 10, 10, 10, 10, 10, and 10. And that's obviously going to be 9 times 10 to the power of 9. Because 9 of these slots have 10 in them. And because they're all multiplying, 9 times 10 to the 9. 10 multiplied by itself, 9 times. Okay. And that's it. That's it for lesson 1. Now, I know your textbook tends to go through things in a very chaotic manner, and I've broken it down into 9 or 10 different lessons. In each lesson, I hope will be very easy to approach and will be easy to understand. So we are going to chunk it up, and we'll take it one step at a time. So hopefully you understood today's lesson, and if you have any questions, you can ask me on Slack. Best of luck with the homework. I will obviously post up the questions onto Slack. Best of luck.